Hello, my name is James Paris White, and I will be performing my presentation on Dr. David Harold Blackwell for my Math 312 class, History of Mathematics. Dr. David Harold Blackwell was born on April 24, 1919, and recently passed on July 8, 2010. Blackwell was born and raised in a small town named Centralia, Illinois, and he was raised by Grover and Anne Blackwell. David Blackwell was married to Anne Blackwell, and they met at Clark-Atlanta University, and we'll get more into that later. Blackwell was a part of Alpha Phi Alpha Fraternity Incorporated, but to be more specific, he was initiated at the Tau chapter of Alpha Phi Alpha Fraternity Incorporated, which is at Illinois University. Blackwell was a very special individual. Before he graduated high school, he already had his first publication. He graduated high school at the age of 16, and he started college very shortly. At the age 16, Blackwell attended the University of Illinois Champaign, and in just 3 years he received his bachelor's degree and master's degree. In 3 more years, Blackwell went on to receive his doctoral degree in statistics, all obtained by the age of 22, as well at the University of Illinois. Blackwell's thesis for his doctoral degree was named The Properties of the Markov Chains. Markov chains are a random set of numbers or events that occur, and one would like to know the probability of the event happening again. For example, we can take a certain amount of students and make a transition matrix. Some kids will be playing on their phone, paying attention, and we will monitor the students that will get kicked out of school. Our transition matrix will look something like this. Along this side, we have what is currently going on, and on the top bar, we will see how it will affect the students getting kicked out. Now I've shown you how the transition matrix will be set up for the Markov chain example. With the equation pi times p equals 1, 0, 0, 0, it'll be times the vectors in the matrix. That way you will see how your numbers will be affected. For time's sake, I will show you guys a flow chart to show you how the numbers will be affected. At the top, we have the number of students arriving. You have to have someone to account for. We will go to this side first. The students that play on their phone. As you can see, that it is a direct correlation of students that get kicked out. On the other side, we have students that pay attention, but there's an if statement there. How long can the students pay attention? After a certain time, will they play on their phone, which will go back to being kicked out, or will they pay attention for the whole class period, and then it would directly affect the graduation rate. Now we can talk about David's years at Princeton University. In 1941, Blackwell was awarded with the Rosenwald Fellowship Award. The Rosenwald Fellowship Award is awarded to one who displays the well-being of mankind. Even with this being said, Blackwell experienced discrimination at Princeton University. For example, he was not allowed into the mathematics building because of the color of his skin. Do you think this stopped Blackwell from being great? Not at all. This fueled him to go beyond measure. So his next step was to apply to all of the historically black colleges in the United States, which was a total of 105 applications. His first profession out of school was to be an assistant statistician at the Office of Price Administration. However, Blackwell did not stop there. In 1 year, he went all the way until Baton Rouge, Louisiana, to be an instructor at Southern University. However, Blackwell felt this wasn't the spot for him. So he made another move to Clark College, now known as Clark-Atlanta University in Atlanta, Georgia. And we can make a pit stop here because this is where Blackwell met his wife, Anne Blackwell. The story goes that Blackwell was getting ready to teach a physics class, and Anne was registered for the class. And then they got married and moved on with their life. However, in just one more year, Blackwell moved back to Washington, D.C. This time was at Howard University. Blackwell will make a pause on his life here, but not a complete stop. He stayed there for 10 years at Howard University, being the head of the mathematics department as well as a full-time professor. In 1954, Blackwell went to Berkeley as a visiting professor, then a full-time professor in 1955. This would be one of his last stops. In 1955, while Blackwell was on the West Coast, he met his mentor, who was Meyer Gerschick, who was a professor at Stanford University at the time. They collaborated and made the book Theory of Games and Statistical Decisions, which was one of Blackwell's more famous publications, but surely not his only. Before Blackwell was even a full-time professor at the University of California, Berkeley, he had already published more than 20 papers. As his summers went on in California, he spent them participating at the Rand Corporation in Santa Monica, California. This is where he wrote papers and reports mainly on military problems, and just because he loved game theory so much, he wrote reports on poker. Once again, back at the University of California, Berkeley, and as his whole life went on, Blackwell experienced discrimination because of the color of his skin. This time, Blackwell was recommended to be the head of the mathematics department at California, Berkeley. However, he was shut down because he was an African American. But once again, this did not stop Blackwell. He just continued to be the man he was and to continue on his everyday life. And just 1 year later, they created a position that was just for him. They started a brand new statistics department and they made him the head of it. And then as soon as that happened, University of California, Berkeley Statistics Department was named as the strongest in the country. From 1973 to 1977, Blackwell expanded his horizon internationally. In those 4 years, he became the director of the University of California Study Center for the United Kingdom and Ireland. He was also the president for the International Association Statistics and Physical Sciences. Also, he became the president of the Bernoulli Society, which we can sidetrack right here, which was made for the statistician Jacob Bernoulli, who gave us the Bernoulli equation, which we use for when we experiment with two possible outcomes, as we can say success and failure. He came up with the formulas this, where our probability mass function equals p to the x times q raised to the 1 minus x, where x has to be 0 or 1. Like I said, failure or success. Our moment generating function is q plus p times e to the t power, where our mean is equal to p and our variance is equal to p times q. Also, in his last years going international, he became the vice president for the International Statistical Institute. As Blackwell's very, very interesting life started to wind down, he retired as a professor emeritus at the University of California, Berkeley, which meant he still hung around giving out his wisdom and his knowledge, helping students, staff members, and really showing why he was awarded the Rosenwald Fellowship Award at Princeton. Dr. Blackwell left us with multiple concepts in his names, lectures in his name, and awards as well. For instance, the Blackwell Tapia Award rewards an African American and or Hispanic outstanding student in the mathematics department. We also have Blackwell Optimal Policies and more. As far as the probability and statistics realm, he left us with a lot, but he was mostly known for the Bayes theorem and the Rao-Blackwell theorem. And I'll give you guys an example of the Bayes theorem problem, of an Bayes theorem problem. For instance, we will say bowl B1 contains 2 white chips. Bowl B2 contains 2 red chips. Bowl B3 contains 2 white chips and 2 red chips. And bowl B4 contains 3 white chips and 1 red chip. The probabilities of the selecting bowl B1, B2, B3, or B4 are, and it goes in order, 1/2, 1/4, 1/8, and 1/8 respectively. A bowl is selected using these probabilities and a chip is drawn at random. Question 1. Find the probability of drawing a white chip. As you can see here, I have already placed our bowl selection probabilities. So for bowl B1, we have 1/2, B2, 1/4, B3, 1/8, B4, 1/8. And the question asks us to find the probability of drawing a white chip. So with Bayes' theorem, we have to find all of the chances of drawing a white chip. So we multiply our selection of picking the bowl B1, B2, B3, and or B4. Those are the numbers that are outside of the parentheses. The numbers inside the parentheses are the number of white chips in the bowl over the total number of chips in the bowl. So for bowl 1, we have a total of 2 white chips over 2 chips. Bowl 2, we have 4 red chips, so we have 0 over 4. Bowl B3, we have 2 white chips over 4 total chips. In bowl B4, we have 3 white chips and 1 red chip, which gives us a total of 4. And we combine our probabilities, we get a total of 21 over 32, which is approximately 66% chance drawing a white chip. Now we go on to part 2 of the Bayes' theorem question, which is find the conditional probability that bowl B1 had been selected given that a white chip was drawn. As we have stated previously, the probability of drawing a white chip is 21 over 32. Now we are looking for the probability that the bowl B1 has been selected when we know that a white chip has been drawn. So we use the formula. B1 over W. In this case, we want to find out the probability of drawing B1, which is 1/2, and the probability of drawing a white chip, which for bowl B1 it happens to be 2 over 2, all divided by the probability of drawing a white chip, which equals 16 over 21, which gives us a 76% chance that bowl B1 had been selected. That sums up our Bayes' theorem problem. I can sit here and list Dr. Blackwell's long, very extensive list of accolades and honors. However, I will just point out a few. Blackwell finished with about 86 research papers, and almost half of them were published in math magazines and scholarly journals. He had received 13 honorary doctorate degrees, and he was the first African American to be inducted into the National Academy of Sciences. Dr. Blackwell left us with a lot of tangible and non-tangible items. His love and passion for math showed me that I can go as far as I want when I use my most powerful weapon, which is my brain. Thank you.